Greetings and welcome to your geometry recording for the week of September 19th. We are also working in week 6 let me start over and try that again. We are working in week 6 this week. And I don't know if you guys knew, I believe it's Friday. Yeah, Friday the 22nd is the official first day of fall. So happy first day of fall. Make sure you've got a math notebook or your math notebook out and that you're ready to take notes. This recording is going to be a lot of review as we are finishing up the Unit 1 and heading into the Unit 1 test this week. So lots of opportunity for review in this recording. And remember, a wonderful way to review is that you've got that option of clicking on the pause button and trying problems on your own, and then checking your work with mine by clicking play and watching the remainder of the recording. So use that to your advantage. Use this recording to get some practice and see what you need to work a little bit more on before you take the unit test, or maybe see what you're really strong with before you take the Unit 1 test. And that brings me to the warm-up question. So we are going to warm up by looking at the distance formula. And we're going to use the distance formula to find the distance between these 2 points, 5, -2, and 0.13. Remember, if you need to refer back to your notes to review what the distance formula is or do a quick web search, do that. So try this in your math notebook. And when you're ready to check your work with mine, click play. So go ahead and click pause so that you can try this on your own first. All right, so let's throw up the distance formula. So let me put that up for you. And ta-da, here it is. So the distance formula, we're finding the difference between our x-coordinates, taking the square of that, adding it to the difference of our y-coordinates and squaring that. So notice that sometimes in the formulas for distance, you might see where they take the x1 coordinate minus the x2 coordinate, and same for the y-coordinate, you would take the x1 coordinate minus your your y2 coordinate. So you can also do start with the second x-coordinate and subtract from it the first x-coordinate. It really doesn't matter which order you go in. The only thing that's important is whatever order you go in for your x-coordinates, you do that same order for your y-coordinates. So if you like starting with the second x-coordinate and subtracting from it the first x-coordinate, that's fine as long as you start with the second y-coordinate and subtract from it the first y-coordinate. So whichever order you like doing, that is okay as long as you're doing the same thing for your x and y coordinates. So here we go. Let's label this as our first x-coordinate and our first y-coordinate because it's our first coordinate. Our second coordinate will make this our second x-coordinate and our second y-coordinate. And we're going to plug these into the formula. So my first x-coordinate is 5 minus my second x-coordinate, which is 1, and I'll square that and just, whoops, I don't know why I put 4 there. I meant to put square that, and then we're going to head on to our y-coordinates. So we're going to take our first y-coordinate, which is -2, and subtract from that our second y-coordinate, which is 3, and then we're going to square that. So let's clean up what we have in our parentheses. 5 minus 4, or 5 minus 1 is 4. I got ahead of myself. And then we'll add to it -3 minus -2. -2 minus -3 is -5. So we'll square that. When we square 4, that means 4 times 4, which is 16. And when we square -5, that's what is negative times -5 times -5. Woo, I'm having trouble here with talking today. -5 squared is the same as -5 times -5, which is +25 is what I was trying to get out. We're going to add that together. 16 plus 25, which is 41. So the square root of 41. And I'm looking to see if I can simplify the square root of 41. There are no perfect squares that are factors to 41, so I'm going to leave that as square root of 41 to be my most exact answer. All right, so I'm going to go on to the next slide. So if you need more time, click pause so that you can finish taking down notes. So what are we doing this week? We are going to finish up Unit 1. Take the Unit 1 test, and because we are finishing up with Unit 1, that makes this the last week to submit redos for Unit 1. This is the last week that I will accept redos for Unit 1. Then we're going to start Unit 2, which is all about triangles. So let's take a moment to do some review for Unit 1 since we are taking the Unit 1 test. Again, I can't review everything, so I'm just going to do a very short condensed review just to get you thinking about some of the stuff you did in Unit 1. A great way to study for the Unit 1 test is to do redos. So redo low scoring assignments. You'll be improving your grade at the same time that you're reviewing and preparing for the Unit 1 test. So that's a great way to prepare for the Unit 1 test. All right, so one of the things we learned about were parallel lines, when we have two parallel lines that are intersected by a transversal. And with that intersection, we have a whole bunch of different angles that are created. And we learned about a lot of the different special angle pairs that are created. So in this question, we want to find the angle measurement of angle GHF. Whoops, GHF, that doesn't make sense. I think it was supposed to be GFE. There we go. So GHE is what it was supposed to have been. So we want to find this angle measurement, GHE. How can we do that? Well, we're given this angle measurement right over here, which is 131. Can we use that to help us find the missing angle measurement that we're trying to find? We can. So first of all, what are these two types of angle pairs? What are these? What is this angle pair? They can be called same side interior angles. They're on the same side of the transversal and they're interior to the two parallel lines. So they're same side interior angles. And what do we know about same side interior angles? They're always going to be supplementary. They're always going to add up to 180 degrees. That's what supplementary is. They add up to 180 degrees. So let's do that. Let's set up an equation. So really, if we take 131 and add it to our unknown angle, we should have a total of 180 degrees. And then we have a simple equation where we can solve for x. So we can subtract 131 from both sides and get our value of x. And our value of x is representing the measurement of angle GHE. So 180 minus 131 is 49 degrees. So that makes the measurement of angle GHE equal to 49 degrees. I'm going to go on to the next slide, so if you need more time, click pause. All right, I'm going to skip this one because we just did a problem like that, and we're going to hop into a little bit of what you're going to see in Unit 2. So please remember to make sure you're taking some time to review Unit 1 before you take the test. And Unit 2 is all about triangles. So in Unit 2, you're going to be learning lots and lots of theorems and postulates. So what would be very helpful is to start a theorems section in your math notebook. So start a section where you know you can keep adding to it, really from here on out till the end of the school year. That way, when you're working on assignments and you're like, ooh, what was that theorem? You can go back to the theorem section in your math notebook and find that really quick. So start thinking of these problems that we're going to be learning about as puzzles, and that you are going to use all your knowledge, such as the theorems you're learning about, as clues that you can use to solve those problems. Quick reminder, just as we still are getting used to how to be successful in our online classes, make sure you're checking your grades. You're clicking on assignments in the grades tab to open those up to see what you missed and read my feedback. Remember, this is the last week to submit Unit 1 redos, and then to message me when you submit missing assignments. All right, so back to Unit 2. I think those slides got a little out of order there. So back to Unit 2 and triangles. So as we start going through Unit 2, you're going to see some notation on the triangles that give us some very important information about the triangles, and I want to make sure that we know what all those notations represent as we start Unit 2. So here we've got a couple different triangles, and you can see on the triangles that they have these different ticks. So some of the ticks are just one ticks. I see there's 2 ticks here and there's 3 ticks here. So what do those ticks mean? They tell us something about the side lengths of our triangles. So when we have the same number of ticks on 2 of our legs, so here we've just got 1 tick and 1 tick, that tells us that the side AB is equal to side, whoops, I meant to say AC. So it tells us those 2 sides have the same side length. They're congruent, they're equal. Notice there is not a tick on BC, side BC, so that would mean that BC does not have the same length as the other 2 sides in this triangle. Looking at this next triangle, I see this leg has 1, this leg has 2, this has 3. So none of these legs have the same number of ticks, so that would mean that all these sides have different lengths. Anytime you have the same number of ticks on different leg lengths, that means that those leg lengths are the same. Looking at triangle C over here, we see that there's a tick and 1 tick on each side, so that would mean that all of these sides are the same length, so that all sides of this triangle have the same length. So those ticks can be very helpful to help us learn about different aspects of the side lengths. So when we start Unit 2, we're going to be learning about 3 different types of triangles. Equilateral is when we've got all sides are congruent. So equal, think of equal, that beginning of the word equilateral, meaning equal. So in an equilateral triangle, all sides are congruent. So can you tell me out of triangle A, B, and C and what you learned about the ticks, which one would be equilateral? If you said C, you're right. I already kind of put that. All sides, oops, that should say all sides have equal lengths. So this is an equilateral triangle. An isosceles is a triangle with 2 sides that are equal. So can you tell me which triangle up above would be the isosceles triangle, A or B? So here there's a tick here and there's a tick here. So we know those 2 sides are congruent, and that third side is not congruent to those. So we know that this would be our isosceles triangle. And then last but not least, scalene, where all sides are different lengths, which would make this triangle right here, triangle B, this would be our scalene triangle, because we've got 1 tick, 2 ticks. and 3 ticks, letting us know that none of those side lengths are the same. So this would be our scalene triangle. I'm going to move on to the next slide. So if you need more time, go ahead and click pause. Otherwise, we're moving on. So more notations to take note of. We learned about notations for our side lengths, but we also have notations used for our angles. So look here, angle U on this triangle and angle X on this triangle have one arc. And then if we look, we see that angle V on this triangle has 2 arcs and angle Y on this triangle has 2 arcs. Well, if there's the same number of arcs on our angles, we know that those angles are congruent. So in this case, we know that the measurement of angle U is going to be the same as the measurement of angle X in the other triangle. Same with then the measurement of angle V is going to be equal to the measurement of angle Y in the other triangle. So it's important to know what the notation means as we jump into Unit 2 so that we understand what information is being given to us by those notations, because that's important information. All right. So, how many degrees are there in a triangle? This is some basic information that we want to know as we move into Unit 2. There is 180 degrees total in every triangle. So if we add all of our angles together, we always get a total of 180 degrees. And we can use this information to help us find missing angles, such as angle A below here. And just to note, so that this arc, I see that there is an arc in here, and I don't want you guys to be confused because I just said, well, if there's an arc here and one arc here, that means they should be congruent. The only time we use those arcs to let us know if 2 angles are congruent is when an angle measurement is not given. That's when we use different number of arcs, is when an angle measurement is not given. But most of the time, if you have one arc, there's going to be an angle measurement given next to it. So don't get those 2 ideas confused there. So if there's one arc and there's an angle measurement given, that's just to say this is what the angle measurement is. But we use the idea of different numbers of arcs when we don't have angle measurements given, and we're using it as clues to know if 1 or 2 angles might have the same angle measurement. So here, looking at this triangle, we can find the measurement of angle A by knowing that there's a total of 180 degrees in every triangle. So what we could do is we could say, well, I know that all my angles, we don't know, I'll say X for the measurement of angle A, has to add up to 180 degrees. And then we'll do the algebra. We'll add together my like terms. So 49 plus 47 gives me a total of 96 plus X equals 180. Subtract 96 from both sides. And we get our value of X, which represents the measurement of angle A. So 180 minus 96 gives me 84. So that means that the angle measurement of angle A would be 84. All right, going on to the next slide, which is the end. I just wanted to give you guys a preview of the notations that you're going to be seeing in Unit 2. So we are ready for the key phrase assignment. So let me put that up really quick. So part of what we talked about in this recording was some notation that you're going to see that gives us some important information about side lengths and angles. So I put up 2 different triangles. We've got triangle ABC and DEF. And what do you know about angle AC and DF? So looking at those 2 triangles and some notations you see, what do you know about side AC and side DF? So the directions, in case you need a reminder for the key phrase, are below. Have a fantastic rest of your week. And as always, let me know if you need any help with anything or have any questions as you do this week's assignments.